Good morning and welcome to our YouTube channel Wireless Tutor. Dear learners, I wish all of you all the best for your upcoming board exam. Stay blessed and and show your ability in your examinations. This is the complete revision series of mathematics and science. So this video is going to be really helpful. And today we are going to discuss about the chemical reaction and equations. So without wasting any more time, let's get started. So, so, dear students, we have seen so many changes around. Like a raw fruit is converted into a ripe fruit. Sometimes also the food we consume that are also digested and gets away from our body in the form of waste. Similarly, if you throw a glass, then that will break. So there are so many changes around us. Like look here, there are some changes. Basically, there are 10 changes I have written here. The first one is melting of wax. This is also a change. Burning of fire or firewood or coal. That is also a change. Breaking of glass into pieces. Ripening of fruits. Change in the state of water. Digestion in our body. Making tools and ornaments from metals. From gold to gold jewelry. And like making axes, spades out of iron, roasting of iron. This is also a thing. Making a delicious dish out of vegetables, cutting a rubber into pieces. So these are so many changes around us. But all of the changes can be categorized into two types: physical and chemical. So changes are of two types: physical change and chemical change. Then let us know what are the physical changes. The changes in which only physical properties of the substances changes and no new substances are formed. This is very important. No new substances are formed. Suppose you caught, suppose you um, cut a cut an apple, cut an apple into several pieces. Then there is no new substances are formed. Each piece is also belongs to apple, so no new substances are formed. If you break a chalk into so many pieces, then no new substances are found, and you will definitely call the pieces of chalk as chalk. So basically, it says that when a changes takes place and no new substances are found, only the shape, size, dimension, these are changes, then that is called physical change. And what are the chemical changes? The change in which new substances are found. This is very important. New substances. What are the new substances? The substances are called new substances because these properties are changed. Suppose wood is converted into charcoal. Charcoal. If wood is converted into charcoal, and if you look, the property of charcoal is quite different to the property of wood. Then you cannot call charcoal as a wood or as a wood or wood as charcoal. So in this case, we can say that a chemical change has taken place. So next, we will know about some of the other changes. Look here, here is water, and if you freeze it, then this will be converted into ice. So the conversion of water into ice is basically a change. What kind of change? This is a physical change. Why? If you melt ice, then that will again convert into water. Or the or we can say that the molecules present in water and in ice both are same. So ice is not a different substance than water. Ice is only a different state of water. So this is a physical change. Next, look at the image. This is a glass bottle, and if you throw it, then this will break down into pieces. Though you cannot get the original bottle from the pieces again, but after melting, then you can get back easily the glass bottle. So in this case also, these are also the materials, or these are the molecules present in glass bottle and pieces are the same. So this is also a physical sense. Next, this is a piece of chalk, and after breaking, then that will be converted into pieces of chalk. So these are also, this is also an example of physical sense. Next, this is a piece of, or this is a brick of gold brick or gold bar, and this is the gold jewelry, and we can again get back the gold bar out of this jewelry. The molecules present inside the gold bar are same as the molecules present in the jewelry. So these are the examples of physical changes. Next, look at the examples of chemical changes. Here, wood. Wood is converted in, when wood is burnt, then that will be converted into charcoal. So in this case, the property of wood is quite different to the property of charcoal. So wood is a kind of substance, charcoal is another kind of substance, and the molecules present inside the wood is quite different to the molecules present in charcoal. So this is an example of chemical change. Look at the example number 2. This is the ripening of fruit. When the raw fruit, this is a raw fruit. When the raw fruit is ripened, and that cannot be reversed, because the composition inside the raw fruit is changed to make a different substance. So this is also an example of chemical change. Look at the example number 3. Here, iron rust. So rusting of iron is also an chemical change. Next, the conversion of milk into curd. This is also an chemical change. Then let us know what are the chemical reactions. So um, chemical reaction is the process in which one or more substance react to form one or more substance with new properties. So this is, we can say that in the chemical reaction, chemical changes takes place. Suppose A is a substance, B is another substance. After the reaction, they forms AB. That means the substances which takes part are called as the reactants, and those substances which are formed are called products. So the reactants are converted into products. So the process in which one or more substance react to form one or more substance with new properties are called as chemical reactions. As we have learned that the substances which participate are called as reactants, and the substances which are formed are called as products. Properties of reactants are different to the property of products. That means the property which takes part, we will learn through examples also. Um, um, Next, no, reactions may be instantaneous or sometimes slow. Sometimes the reaction may take more time, or sometimes that may also take less time. So take example of crackers. If you fire crackers, then then the reaction will take place instantaneously. That will lead to the production of enormous amount of heat and light. But in some examples where the precipitates are formed, then that may take 1 or 2 days, or 1 or 2 hours. So these reactions are slower. Here, look another example. In this case, you can see that, look at the video. So in this reaction, what happens? We burn magnesium. This is the magnesium reborn. When it is born, it burns with a bright flame, bright white flame, bright white flame, bright white flame to produce a white colored, bright white colored powder that is called magnesium oxide. This is magnesium. When it burns in the presence of oxygen, then it produces magnesium oxide. Can we get back the original magnesium reborn out of magnesium oxide? No, we cannot get back. So this is a chemical reaction. So magnesium reacts with oxygen to produce magnesium oxide, which is white amorphous in nature. Amorphous in nature. That means this is a powder in nature. So we can write the states. We can write as here solid and oxygen exist in gaseous state, and magnesium oxides exist in solid state. Next, how can we know that a chemical reaction has taken place? So in order to know the, the chemical reaction has taken place, there should be the presence of these five effects. The first one is the change in state. The state of the reactant should be changed. The change in color. That means the reactant's color is different to the color of the product. In some reactions, temperature of the reactant also changes. That means heat is absorbed or is released. And in some reactions, the gases are also evolved. Number five, sometimes precipitates are also formed. If there is presence of at least one of these five conditions, then we can say that a chemical reaction has taken place. Next, the first one, change in state. The physical state of the substance change in some chemical reactions. Look at example number one. In this case, H2 plus O2, which gives H2O. In this reaction, we can say that hydrogen exists in gaseous state, oxygen also exists in gaseous state, but the water that is produced exists in liquid state. That means the gaseous substances are converted into liquid state. So in this example, we can say that the change of the reactant has been changed. Example number two, carbon exists in solid state and oxygen exists in gaseous state. But the carbon dioxide is also in gaseous state. That means the solid form of carbon is converted into gaseous state of carbon dioxide. In this example, change in the change of reactants has been changed. Next, change in color. Uh, Look at the example number one, copper. Copper is golden brown in color. You can see that this is copper. The color of copper is golden brown. When you burn copper in the presence of oxygen, that will uh, that will be changed into black color. This black color is nothing but the copper oxide. This is a chemical substance. So the golden brown color of copper is changed to black color. So this is an example of change in color in chemical reaction. Look at example number two. On heating, the green color of ferrous sulfate. Ferrous sulfate is green in color. That is green in color. If you burn it, then that will be converted into reddish brown color. Reddish brown color indicates the formation of ferric oxide. This is this is reddish brown, reddish brown, reddish brown color. Next, change in temperature. Uh, Look at the image. In this image, you can um, see that some bubbles are coming out of the reaction. So, so know about the experiment. bring some amount of calcium oxide, which are powder in state, and add this calcium oxide in some amount of water present in the beaker, and after some time toss the surface of the beaker, and you will notice that some amount of heat is produced because the beaker will be warm after some time. So this warm beaker indicates that heat is produced. Heat is produced. Heat is produced. So in the chemical reactions, change in temperature is evident from this example. Now look about the evolution of gases. That means in the chemical reactions, gases are evolved. In this example, zinc granules are added. These are the zinc granules are added in dilute sulfuric acid. In dilute sulfuric acid, then zinc sulfate is produced along with hydrogen gas is liberated. Hydrogen gas is liberated. So this is the bubbles shows the presence of hydrogen gas. And how to check whether the gas is hydrogen or not? Just bring a candle near the liberation tube. Then you will notice a pop sound. So this sound indicates that hydrogen gas is burnt in the presence of oxygen. Next, formation of precipitates. In some chemical reactions, some water insoluble substances are formed. So those water insoluble substances are called as precipitates. Look at the example. If you add sodium sulfate, that is called Na2SO4. This is called sodium sulfate. Sodium sulfate. Sodium sulfate. When sodium sulfate is added to barium chloride, this is barium chloride. Barium chloride. Then sodium chloride is formed, and the water insoluble precipitate is formed. This is white colored precipitate. White precipitate. So this white precipitate is water insoluble. So sometimes in the chemical reactions, precipitates are formed. So these are the 5 effects during the chemical reactions. Now let us know what is the chemical equation. What is a chemical reaction? We have already learned. Sodium metal react with aqueous hydrochloric acid to produce sodium chloride and hydrogen gas. This is a two-lined reaction. This is boring. If we learn in this way by writing the reactions line by line, then we'll get bored, and most of the informations are also not presented here. So we can write this chemical reaction in short form. So the brief representation of a chemical reaction in terms of symbol and formula is called a chemical, or gives rise to a chemical equation. So this reaction can be written in very short form. We can write Na plus HCl, which gives NaCl plus H2. Na is the formula of sodium. HCl stands for the formula of hydrochloric acid. NaCl stands for the formula of sodium chloride, whereas hydrogen H2 stands for the formula of hydrogen gas. And here you can notice plus sign and arrow mark is given. So these are the symbols. These are the symbols indicated. So when a chemical reaction is represented briefly in terms of symbols and formula, then that is called a chemical equation. So what are the chemical equations? On the basis of the writing, how we write on that basis, we can categorize chemical reactions into two types: word equation and symbolic equation. Look at the left side. The reaction statement is magnesium reacts with oxygen to form magnesium oxide. In this reaction statement, we can write in two forms. Word equation, magnesium plus oxygen, which gives magnesium oxide. These are the words. So this is called a word equation, but we can also symbolize Mg for magnesium, O2 for oxygen. So this is a symbolic equation. So on the basis of the number of atoms present in the reactant side as well as number of atoms in the product side, we can categorize chemical equations into two types: skeletal equation and balanced equation. Look at the right side. Here is the skeletal equation, and if you will notice, there is a single magnesium atom present in the reactant side. There is also a single magnesium atom in product side. But look at the case of oxygen. There are two oxygen atoms in the reactant side, but there is a single oxygen atom in the product side. That means the number of atoms, the total number of atoms present in the reactant side is 2, but the total number of, sorry, the total number of reactant atoms present in the reactant side is 3, but the total number of atoms present in the product side is only 2. So in this case, we can say that the number of atoms is not balanced here. So the unbalanced chemical equations are called skeletal equations. So in the case number 4, here the chemical equation is balanced. M- Magnesiums are also balanced and oxygen is also balanced. Next, we have got a pre-introduction of balanced chemical equations. Then we should know, why should we need to balance a chemical equation? This is not reaction, this is equation. This is equation. Why do we need to balance a chemical equation? The first one is law of conservation of mass. Law of conservation of mass says that in a chemical reaction, mass can neither be created nor destroyed. That means, suppose A plus B, which gives C plus D. That means the total mass of A plus B, or the combined mass of A and B, must be equal to the combined mass of C and D. This says the law of conservation of mass. So the total mass of the reactant must be the same as that of the product. So the total number of atoms present in the reactant side must be equal to the total number of present in product side. Suppose there are 10 atoms present in reactant side, then there must be 10 atoms in the product side. The balanced equations give more information about physical states of chemical substances. So due to all of these reasons, we need to balance the chemical equation. Next, look at the example number 1. This is the skeletal equation, and in the equation number 2, that is balanced. Look at the number of magnesium in the first equation. In the reactant side, one magnesium present. In the product side, one magnesium present. So magnesium is balanced. But look at the case of oxygen. There are two oxygen atoms in the reactant side, but there is a single oxygen atom in the product side. So oxygen is unbalanced. So where does this extra oxygen goes? So according to the law of conservation of mass, oxygen should remain in this reaction. Just we need to balance the chemical equation. Just write 2 in front of Mg and write 2 in front of MgO. Then magnesium is balanced. In order to balance oxygen, just write, um, we have already written 2 in front of MgO. So this is a balanced chemical equation. Look at the example number 2. This is the skeletal chemical equation, HgCl, which gives Hg plus Cl2. You can see that chlorines are not balanced. there is one chlorine atom in reactant side, but there are two chlorine atoms in the product side. But after writing 2 in front of AgCl and in front of Ag, we have a balanced chemical equation. Next, steps to balance a chemical equation. What are the steps and how can we balance a chemical equation? There are some steps which we can follow to balance most of the chemical reactions. But these steps are not the superior. We can also balance chemical equations into different types. If you have not watched my how to balance chemical equations, then please visit my channel and you can watch this video. Then first step is just construct boxes around the formulas and chemical substances. Why? Suppose suppose a chemical substance is present H2O, another chemical substance that is H2O2. The elements participate in water are hydrogen and oxygen. The elements present in hydrogen peroxide, this is called hydrogen peroxide. This is called hydrogen peroxide. So the same kind of elements present, but but the hydrogen and oxygen are engaged in 2:1 ratio. In the second case, they are in 2:2 ratio. But if you notice the property of these two chemical substances, those are quite different. Suppose you have not written the formulas and you need to balance and you wrote 2 after O in the water, then that will be converted into a different kind of substance. We we consume water because it is our lifeline. But H2O2 is a poisonous liquid that is basically used to remove wax from our ear. So this composition changes the entire property of this chemical substance. So we need to write formulas around the chemical substances so that their formulas should not be altered or should not be changed. Number two, construct a table representing the number of atoms of each element of both reactants and products. Then, so that just look at the table. We have written there are three columns basically. The first column represents elements. The second column represents the number of atoms in the reactant side. The third column represents the number of atoms in the product side. Number third, start balancing, or it is convenient to balance or to start balance from the element which is the higher number of atoms. Number four, balance the remaining elements. Suppose one element is balanced, then just balance the remaining elements. In the case number five, uh, in the step number five, just write down the physical states of the chemical substances. I will show how to balance a chemical reaction in out of these 5 steps in the next slide. Here is the balanced chemical, uh, here is the unbalanced chemical equation. This is the basically skeletal chemical equation. And you have seen that there are the boxes which are constructed around the chemical formulas of the chemical substances so that their formulas should not be altered. Because I have already told you, in order to balance 4, you suppose you wrote 4 here, then this is a wrong way. We cannot balance in this way. We need to balance just writing the coefficients or stoichiometric coefficients which we say those are the stoichiometric coefficients. What are the stoichiometric coefficients? The coefficients written in the previous of the chemical formulas. Next, we have plotted a table showing the number of atoms of each element from both reactants and products. In the case of iron, in the reactant side, there is one atom. In the product side, there are three atoms. In case of hydrogen, there are two oxygen atoms in reactant side. There are also two atoms in product side. That means hydrogen is balanced. But in case of oxygen, there are four hydrogen atoms in the product side, but there is one hydrogen atom in the reactant side. So um, our step number two is complete. Just write down, just go through the step three. What does the step three shows? Step three shows that we need to balance the chemical equation from that element which has the higher number of atoms. So in this case, oxygen has the highest number of atoms, so it is convenient to balance from oxygen. In order to balance oxygen, just write 4 in front of H2O. Then the number of atoms of oxygen is balanced in both these cases. Both has 4 atoms. Now we need to balance the remaining elements. Step number 4. Here 2 into 4, 8 hydrogen atoms present in reactant side, but there are only 2 hydrogen atoms in the product side. So we need to write 4 in front of H2. Then number of hydrogen is also balanced. Now we can check we can check number of atoms of iron in reactant and product side. There are 3 oxygen atoms in the product side. There is 1 oxygen atom in the reactant side. So in order to balance iron, we need to write 3 in front of iron. Now check out the number of atoms in both reactants and products. Then we will notice that there are 3 iron atoms in reactant side. There are also 3 atoms in the product side. There are 8 hydrogens in reactant side. There are 8 hydrogens in the product side. There are also four oxygen atoms in both reactant and product side. We need to write the physical state. So in order to write the physical states, we need to know the reaction first. What is this? This is iron. Iron only reacts with vapors to form the rust. That means iron must be in the solid state and water must exist in the gaseous state. And as you know that water exists in the gaseous state, and this is called ferric oxide. This exists in the solid state. Now we got a complete balanced chemical equation. Next, this is the task for you to balance the chemical equation. Just take the screenshot and balance. Now we will learn the type of chemical reactions. We have learned about the chemical reactions. There are 3 bases on which we can categorize chemical reactions. On the basis of number of reactants or products participate or formed, there are 4 kind of chemical reactions: combination, decomposition, displacement, and double displacement. Similarly, on the basis of heat change, there are two type of chemical reactions: endothermic and exothermic. Similarly, on the basis of loss or gain of oxygen or hydrogen, this is oxidation and reduction. Wait a minute. Sorry. Next, let us know what are the combination reactions. According to the definition, a chemical reaction in which 2 or more reactants combine. There should be more than one reactant. It is not the matter how many products are formed. There should be more than or two plus reactants in the reactant side, and there must be a single product in the product side. Then this is a combination reaction. You can write this also in this way: AB plus CD. There are two reactants, and ABCD is a single product. So this is also a combination reaction. You can also write A plus B plus C plus D. There are four chemical reactants, and out of which ABCD is a single product formed. This is also a chemical reaction. Example: copper react with oxygen to form copper oxide. In this reaction, you can see that there are two reactants, copper and oxygen, but copper oxide is a single product. So this is a combination reaction. So combination reaction is termed out of the number of reactants and number of product formed. Second example, N2 plus 3H2, which gives 2NH3. In this reaction, there are also two chemical substances which participate to form a single product. So this is also combination reaction. In this reaction also there are two reactants and there is a single product. Next, in this reaction also there are two reactants and there is a single product. So all are the examples of combination reactions. Next, decomposition reaction. What are the decomposition reactions? The chemical reaction in which one reactant, that means it is the opposite of combination reaction. That means suppose there is a chemical substance AB and that splits into two simpler products A and B. Then this is a decomposition reaction. Look at the second um, second equation, ABCD, which gives AB plus CD. That means there are two products are formed from single reactant. This is also a, an example of decomposition reaction. Example, lead nitrate breaks down in the presence of heat. Del symbol indicates the heat to form lead oxide, nitrogen dioxide, and oxygen. This is gaseous in state. This is also gaseous in state. Lead oxide in solid in state. In this reaction, you can notice that there is a single reactant, but there are so many products. So this is a decomposition reaction. In the example number 2, carbonic acid also breaks down to form carbon dioxide and water. This is also an example of decomposition reaction. Next, then look at the types of decomposition reaction. There are basically three types of decomposition reaction. Thermal decomposition reaction. Second one is electrolysis or electrolytical. Electrolysis or electrolytical decomposition. Number third, photochemical decomposition. Photochemical decomposition. Thermal decomposition. Thermal means heat. When the decomposition reaction is carried out in the presence of heat, that is called thermal decomposition reaction. Example 1, when you heat calcium carbonate, then it breaks down into calcium oxide and and carbon dioxide. This reaction is carried out in the presence of heat. So this is a thermal decomposition reaction. In the example number 2, ferrosulfate breaks down into ferric oxide, sulfur dioxide, and sulfur trioxide. This is solid in nature in state. This is gaseous in state. This is also gaseous in state. And ferrous sulfate, that is also gaseous in solid in state. Ferrosulfate breaks down to form ferric oxide, sulfur dioxide, and sulfur trioxide. Next, electrolytic decomposition. Understand the experiment first. Just take a mug. make two holes at the bottom of the mug, insert two graphite rods through, through the two test tubes, and just pack with two rubber stoppers so that the water cannot drop to the bottom, and pour some amount of water inside the mug and connect the two ends of these carbon rods or graphite rods with the help of a plug key and a battery. It is ideal to conduct the experiment with a 6-volt battery and add a few drop of few drop of sulfuric acid inside the water, and now switch on the circuit. Then you will notice that some bubbles are coming out of the coming out in the test tubes. So what is electrolytic decomposition? The reaction in which compounds decompose into simpler compounds because of passing of electricity. This is called, or in the presence of electricity, this is called electrolytic decomposition or electrolysis. Example, this is the electrolysis of this is the electrolysis of water. In the electrolysis of water, two reactions takes place. The first one is at cathode and the second one is at anode. Water breaks down into two ions, H plus ion and O2 minus ion. And the positive ions move towards cathode and the negative ions move towards anode. So at cathodes, hydrogen ion gains electron to form hydrogen gas. So hydrogen gas is liberated at cathode. Similarly, O2 minus ion releases electron to the anode to produce oxygen gas. So oxygen gas is produced at anode and hydrogen gas is produced at cathode. Similarly, if electrolysis of hydrochloric acid takes place, then hydrogen gas will be produced at cathode and chlorine gas will be produced at anode. That means the positive charge will move towards cathode and the negative charge will move towards anode. Next, photochemical decomposition. Photo means light. Photo means light. When the decomposition reaction takes place in the presence of light, then that is called photochemical decomposition reaction, or sometimes this is also called as photolysis. Example, silver chloride breaks down in the presence of sunlight. When the reaction takes place in the presence of sunlight, this is in the presence of sunlight to form silver and chlorine. This is called photochemical decomposition. Another example, silver bromide. This is silver bromide that splits in the presence of sunlight to form silver and bromine. Bromine, remember, bromine exists in liquid state, whereas chlorine exists in gaseous state. So sometimes questions are also asked: which chemical substance is used in white, black and white photography? Then the answer is silver chloride, because silver chloride has a very light sensitivity. It is very light sensitive, so that due to its light sensitive, it is used in black and white photography. Next, displacement reaction. Displacement reaction means, suppose A is a highly reactive element, then the B, then A can displace B from its compound and form its own compound AC. And B is displaced, so that this is called displacement reaction. Then, according to the definition, the chemical reaction in which a more reactive element displaces a less reactive element from its compound is known as displacement reaction. Displacement reaction is also called substitution reaction or single displacement reaction. Example, If iron react with copper sulfate, as iron is more reactive, it is more reactive than copper, so it can displace copper and form its own compound, ferrous sulfates and copper. Look at the experiment. Just bring two iron nails and immerse in the copper sulfate solution. After some time, the green color of copper sulfate solution, sorry, the blue color, copper sulfate is blue in color. The blue color of copper sulfate solution fades away, and the copper nails becomes brown in color. So this brown color indicates the deposition of copper over the iron nail, and this solution becomes pale green. In this case, iron displaces copper. Next, in order to know which one is more reactive and which one is less reactive, just remember this series. From the up to down, the reactivity decreases. Potassium is the highly reactive element, followed by sodium, then calcium, then magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. There is a song, reactivity song that is called, that is, please stop calling me a careless zebra. Instead, try learning how copper and silver shapes gold, how copper shapes gold, and then platinum. This is the song. You can remember this song um, to solve all of the displacement reactions further. These are also two examples of displacement reaction. Look at the first equation. Aluminum react with ferric oxide to produce aluminum oxide and iron. Since aluminum is more reactive, as you can see that aluminum is placed over iron. Here is iron and here is aluminum. So aluminum is more reactive. It has the power to remove iron from its compound. But iron cannot displace aluminum from its compound. So, so no reaction takes place in this case. Remember. Another example, suppose it is written that potassium plus zinc sulfate. Then what happens? Then potassium sulfate plus zinc is formed. But if it is written zinc plus potassium sulfate, then no reaction takes place. Why? What is the reason? Because potassium is more reactive than zinc, but zinc is less reactive than potassium. Next, double displacement reaction. Suppose AB is a compound and CD is another compound. Then the exchange of ion takes place between AB and CD. That means A moves towards A moves towards D and forms AD, and C moves towards B and forms CB. Remember, remember this cannot be BC because C is the positive ion and positive ion must be written first. So what is a double displacement reaction? The chemical reaction in which the exchange of ion takes place between two ionic compounds to form new compounds. When the exchange of ion takes place, then that is called double displacement reaction. Look at the example. Sodium sulfate. Sodium sulfate splits into Na plus and SO4 2 minus. Again, barium chloride splits into Ba plus 2 and Cl minus. When exchange of ion takes place, sodium ion react with chlorine ion to form sodium chloride, and barium ion react with sulfate ion to form barium sulfate. So you have already learned that barium sulfate is a precipitate. Precipitate. Sometimes these double displacement reactions are also called as precipitation reactions. So it is solid in state, and notice all of these are in aqueous state. Next, on the basis of heat change, there are two kind of chemical reactions: endothermic and exothermic reactions. Endothermic reactions are those chemical reactions in which heat is absorbed. When we need heat to conduct the chemical reaction is called endothermic. When heat is liberated, that means heat is produced out of the chemical reaction, that is called exothermic chemical reaction. Look at some example of endothermic photosynthesis. In the photosynthesis, it requires sunlight. So heat is absorbed. When heat is absorbed, then that is an endothermic. When heat is liberated or heat is released, that is called exothermic reactions. Another example of endothermic: calcium carbonate breaks down in the presence of heat. That means heat is required. It is uh, an endothermic reaction. But look at the examples of exothermic: burning of methane. When methane bonds, when methane bonds, it produces a large amount of heat. Large amount of heat. So this is an example of exothermic reaction. So the reaction of calcium oxide and water, that also produces some amount of heat. This is also an endothermic reaction. Next, redox reactions. On the basis of gain or loss of oxygen, or gain of loss of hydrogen, and gain of loss of electron, chemical reactions are categorized into oxidation and reduction. What is oxidation? The chemical reaction which involves gain of oxygen. Remember, gain of oxygen, gain of oxygen, and loss of hydrogen and loss of electron. That is called an oxidation reaction. Look at the example: gain of oxygen. Here, copper gains oxygen to form copper oxide. So this is an oxidation reaction. In this case, zinc also gains oxygen to produce zinc oxide. This is ZNO, small n, ZNO, zinc oxide. This is also um, an oxidation reaction. But again, you can notice that lead oxide loses electron. That means oxidation and reduction both are carried out simultaneously. These are carried out simultaneously at a time. So these reactions are combined called as redox reaction. Next, loss of hydrogen. Here, ammonia loses electron to form nitrogen. So this is an oxidation reaction because here loss of hydrogen takes place. Similarly, in the second case, hydrogen sulfide loses electron to form sulfur. So this is also an example of oxidation reaction. Wait a second. Loss of electron. Copper loses electron to form copper ion or Cu plus 2. So here it loses electron. That means it is an oxidation reaction. Similarly, sodium loses electron to form Na plus. This is also oxidation reaction. Next, reduction. It is opposite of oxidation. That means It is loss of oxygen, gain of hydrogen, and gain of electron. Loss of oxygen. Look at the example. Loss of oxygen. Fe2O3 loses electron to form Fe. This is the loss of oxygen. So this is called reduction. On the other hand, carbon oxide gains oxygen to form carbon dioxide. This is oxidation. So oxidation and reduction takes place simultaneously. So this is a redox reaction. In the second case, carbon dioxide gains hydrogen. So it forms water. So this is reduction. Similarly, chlorine gains electron to form chlorine minus ion, Cl minus ion. So this is an anion. Generally, the formation of cations leads to oxidation and formation of anion leads to reduction. Next, there are two examples of redox reactions. Um, Let us know what type of questions are asked. In this reaction, copper oxide react with hydrogen to form copper and water. In this reaction, copper oxide loses electron. That means copper oxide. What happens when oxygen is lost? Then that is reduction. Is reduced to how to write? Copper oxide is reduced to Cu. Similarly, in the second case, we can write H2 is oxidized oxidized to H2O. Let us introduce two new terms. The chemical substance which is reduced itself, then it oxidizes the others. So it is called oxidizing agent. Oxidizing agent. Similarly, in the case of hydrogen, it is oxidized itself. So it reduces the other. So it is called reducing agent. Reducing agent. Look at the example number 2. Here Fe3O4 react with hydrogen to produce iron and water. So in the first case, Fe3O4 loses oxygen. So removal of oxygen leads to reduction. So how to write? Fe3O4 is reduced to Fe. Similarly, H2, 4H2 is oxidized to 4H2. Which one is oxidizing agent? Fe3O4, obviously, because it is reduced to itself. So this is oxidizing agent, and 4H2 is the reducing agent. Next, this is the last concept: application of oxidation in daily life. Let us know what is corrosion. Generally, when metals are left for a long time, this is the rusting of iron. Rusting of iron. This is the green coating on copper. This is the blackening of silver or manganese. So all these three cases, when metals are exposed for a long time into air and humidity, then they are corroded. They are corroded, or or their surfaces are deteriorated or degraded. So this process is called corrosion. So corrosion is a process through which refined metals are converted into more stable compounds such as metal oxides, metal sulfate, and metal hydroxide. So it is a gradual deterioration, that means degradation of not metals, materials, metals by chemical or electrochemical reactions in the or with the environment. So this process is called corrosion. Example: rusting of iron, green coating on copper, blackening of silver ornaments. Next, rancidity. Rancidity means when fat containing foods are exposed to air, then oxidation of food takes place. Oxidation of food. So when oxidation of food takes place, some bacteria, some bacteria, some bacteria are grown rapidly, leading to the formation of some toxic or some poisonous substances. And um, as a byproduct, a bad smell or pungent smell comes out of this process. So this process is called rancidity. Then look at the definition. When a fat or oil catalyzed by exposure to oxygen heat lead to heat or light leads to production of peroxide derivatives, release bad pungent smell. This is called rancidity. So rancidity is a term used to describe the spoilage of foods products that contain oil and fatty acid by bacterial activity. Next, how to prevent rancidity? Prevention of rancidity by keeping food into airtight containers so that we can prevent the presence of oxygen um, near the fats or oily substances. Second, preventing the presence of oxygen. Number third, adding antioxidants. So antioxidants are those substances which prevent further oxidation. Checking the bacterial growth. We can check the bacterial growth by adding preservatives. Adding preservatives. What are the preservatives? Suppose um, we add we add we add sugar or jaggery in the pickles mean achar pickles so that we can check the bacterial growth. So keeping snacks in nitrogen containing chips packet. So nitrogen also reduces the growth of bacterial activity, so that also prevents transmission. So this is all about the first chapter. If you find this video helpful, then kindly support and wish you all the best for your upcoming examinations. Jai Jagannath, Jai Hind.